Hello everyone and welcome. Today we are going to explore the technical side of my VoxelEngine. Last time we had a quick look about the project and its history, but now we are going to get into the thick of it and get a good view of its inner workings. The first challenge I faced when starting the VoxelEngine project was how I could get all of my voxel data, which is initialized on the CPU, to my shader that runs on the GPU. After a quick Google search, I stumbled across multiple solutions such as uniform blocks and shader storage objects. And after a bit more research, I settled on using SSBOs. And that's when the real challenge began. When using an SSBO, the convention is to use the STD140 layout. The latter was quite hard for me to set up, and that day I even ended up asking my first ever Stack Overflow question about how to parse arrays of structs using the STD140 layout. In the end, I realized how stupid I was, and instead of parsing in structs, which is possible but quite complicated, I just had to pass in a vector for each voxel. In reality, this makes a ton of sense, and I should have probably thought about it faster, as a voxel is basically a 3D pixel and thus should have a color and an alpha value, both of which fits exactly in a vector form. Now, some of you may be asking, Alex, if you're using a vector 4 to represent the color, how do you get the position? Well, the answer is quite simple. The voxels are essentially fixed to a 3D grid. Thus, each voxel can be accessed just by using its 3D index that is easily converted to 1D, like this. With that setup, and by following this basic concept, the chunks are quite easy to set up too. For my code, each chunk has a position and is fixed to a 3D grid. In the future, I would like to expand this a little more and use some techniques in order to reduce the amount of useless steps my remarcher has to do. But for now, let's focus about the chunks. As stated in the previous video, the chunk loading and unloading is all determined by the distance of a camera from the center of a middle chunk. When a chunk needs to be loaded or updated, its index is pushed to a queue. The latter is checked every frame and a thread is launched to update the chunk at the top of the queue. This allows our program to continue to run even when updating chunks. Using a queue also results in smoother frame rates as the work is shared along several frames instead of just doing it all at once. This considerably reduces any stutters. Also, the chunks are stored in ascending order from the camera. This is done so that during the remarching, the algorithm has to deal with less overdraw, thus resulting in less work done for nothing. This is because, in my context, an overdraw is just when I march through a chunk that will never be seen from the camera at this current position. Well, with the chunks and voxel data setup, I wanted a way to efficiently be able to voxelize 3D models. To be honest with you, this isn't going great for the moment, but things are in motion, and here is what I've come up with for the moment. To convert 3D rasterized models, I basically issue a normal draw call to OpenGL. And instead of using a normal fragment shader that just calculates and outputs the final color, I use my fragment shader to calculate the color along with the position in world space of a fragment. Using this position in world space and the calculated color, I am able to set the corresponding voxel to the color that the fragment is. And when testing this with this model from learnopengl.com, we can see that some triangles, or voxels in my case, are missing. I have yet to find a solution for this, but it's coming soon, don't worry. Another side of my engine that has not been going great for the moment is the whole voxel tree, and more specifically the sparse voxel tree that I have talked about in my previous video. Well, it isn't that bad. I've got it working on the CPU side with the construction and sending of data. However, actually using it in the remorcher is a pain in the ass, and I don't know if I have footage about this, but it usually results in a lot of artifacts and sometimes even loss of performance. Once again, I'm gonna tackle this later on and hope that it works. Anyways, enough talking about all the bad stuff, and let's focus on what works. So, since the last video, a lot has been done. Essentially, I've done a lot of code cleanup for you guys to understand it better. Also, I have updated the way I calculate my redirection by using the projection matrix instead of only the view matrix. Later on, this will allow me to do some cool stuff using a hybrid technique of voxels and rasterization, in which I will be able to overlay 3D models or particles on top of my current voxels. Except from that, I also added this beautiful sky that is rendered using this simple function. To end today's video, I want to quickly highlight that due to the grid-like nature of my engine, it is quite easy to render shapes that can be represented mathematically. Such as this heart, for example, that may or may not have been a Valentine's Day gift this year. Thanks everyone for watching, and if you want more content like this, or if you want to see what's coming next, you can,